Okay, let's take a look at this question here. So we have a goodness of fit test, and these are kind of our null hypothesis value. Not kind of, they are our null hypothesis proportions here in the first survey. And let me go through the first couple questions aren't too bad. Null in general always means nothing. So the attitudes have not changed over time. That's going to be our first answer. So here, what the null hypothesis means in our goodness of fit is not necessarily the proportion of each category is the same. What we want to know is each second survey the same as what it was years ago in the first survey? So we want to know if the optimistics equals 0.43, the slightly optimistic is 0.17. In other words, are they the same as the previously given values? Okay, and then like I said, it's just looking here at the first survey for the null hypothesis. So if nothing has changed, then the second survey proportion should not be significantly different from these proportions right here. Okay, and then we get the expected value for the number of respondents who are optimistic. So here we have to go up and look at whatever the sample size is. So here we have 350 times, what did we say? Optimistic, 350 times 0.43. And this gives us 150.5. Let's go ahead and put 150.5. And then we're going to do the same thing on this one, slightly pessimistic. That's going to be 0.23 times our 350. So 0.23. And that'll give us 80.5 here. By the way, I'm going to do something here in the next step that you could do early on and then use that for the previous two steps I did. It could make it easier. I'll mention that when I get to it. So here's the big question. What's our chi-squared test statistic? So here's where the TI, unfortunately, and I'm not sure about the Casio, but they're going to run you into problems. If you take these numbers times 350, as you should, that's what you should do, you'll get a decimal answer which will give you an error on the calculator. If you round that to the nearest integer for each of these categories, these 8 categories, then your chi-squared statistic will be probably a little bit too far off for Hawks to count it correct, and so you're kind of pinned in a corner. So what they're kind of encouraging you to do here is actually do the test by hand, which to me means using Excel. So if I copy the data here, and then I'm going to pull up an Excel sheet, and let me just paste that. I did a Control V, or it's a Command V on a Mac, and that gives me my data here. These are my expected, or sorry, yeah, these are my expected values here. But what I need is the expected numbers. So let's do expected observed. Now remember, I have 350, so here I'm just going to take equals each of these proportions times 350. Of course, that would be different if your sample size was different. You can just drag that formula over and down, and notice that we do have some decimals there, which would give us an error in the calculator. And then we can get our chi-squared values. So this is a formula. Again, you don't have to memorize this. You can write this in your notes, but it's observed minus expected squared. Now we want that quantity on the top of our fractions. We're going to have to put another set of parentheses around all that, and then divide it by expected there. So observed minus expected, that quantity squared, divided by expected. Make sure you watch those parentheses closely. And you may even try it in your own spreadsheet with the numbers that I have here, just to make sure you get that formula right. Okay, so we're going to get a chi-squared value for each entry that we have here. Notice that, by the way, the higher the chi-squared value, the more that particular category was off from what it was expected to be according to the null hypothesis. So here we can see none of them are too far off. The pessimistic, we expected 59.5 and got 52.5. That was our biggest deviation. Now our chi-squared statistic then, so chi-squared stat, that's just a matter of adding up the individual chi-squared values here. So we're, oops, I need a little sum in there, SUM. And that should give us 2.370, what do we need? 3 decimal places. Let's try that again. 3 decimal places would be 2.371. And let's try that. And that should work. And then the degrees of freedom, now this is a chi-squared goodness of fit, so we really only have 4 values that we're looking at, 4 in the expected, 4 in the observed. And so the degrees of freedom is just going to be 1 less than that, which would be 3. Okay, and now we need the critical value at the 0.005. So if we go to tables, chi-squared, we're looking for the critical value at 0.005. Let's see if we, right there, the very last column for us. And remember we said 3 degrees of freedom, so that would be 12.838. So in other words, to reject the null, we're going to need to get beyond that. The chi-squared is always a one-tailed test here. Okay, and now we need to get the p-value. Okay, so in order to decide whether or not this was oh, you know what? We actually don't need that because we know what our chi-squared statistic is, 2.37. And on a goodness of fit, we have to be beyond the critical value. Well, we just found the critical value was something like 10. We're certainly not beyond that. So our answer should be that we're going to fail to reject. We did not get beyond, we did not get further out in the tail than our critical value. However, we could also get the p-value here. Just in case you would need the p-value, or it can help you confirm your decision to fail to reject the null here. So we could do equals and then start typing chi-squared. I don't really remember this or memorize it here, but chi-squared distribution right tail. We want the amount out in the right tail for this particular test statistic with 3 degrees of freedom. And that's going to give us 0.499. So again, the decision to reject the null and find statistical significance, that would be if our p-value was below our alpha level, which I think in this case was 0.005 or something like that. So clearly we're well above that, which means we have no chance of rejecting it. This is fail to reject. We do not have statistical significance here. And let's see. So failing to reject means there's not enough evidence to confirm that anything has changed.